Hey trigonometry class, this is our lesson on section 2.1. We're going to be looking at trigonometric functions of acute angles. So all of our angles are going to be in that first quadrant of what we've been looking at in the previous chapters. Okay, so the first thing we're going to be looking at is a right triangle base definition. These are the definitions that we have learned before in our geometry class on what sine, cosine, tangent, and the other three are. And then we're going to be looking at something called cofunctions, and then we're going to find some trigonometric function values of special angles. And we've also looked at these special angles before in geometry class. Those angles are the 30, 60 degrees and like a 30, 60, 90 triangle and a 45, 45, 90 triangle. Those were two special types of triangles that we looked at in geometry, and we are covering them again here in trig. So let's move on. Okay, so what we have learned before in trigonometry is given right here, the y over r, x over r, and y over x, definitions of sine, cosine, and tangent, and then their reciprocals. But here are the things that we have learned before in geometry to coincide with these things. So sine of A equals y over r. If you look down at this triangle right here that I have drawn, you would see that sine of A, or angle A, is right here. Y is our opposite side, and R is our hypotenuse. So we get opposite over hypotenuse. And now we have cosine of A is x over R, and you'll see that x is our adjacent side on our triangle, and again, R is the hypotenuse. And tangent is y over x, which is our opposite side, y over x, our adjacent side. And then we get secant, cosecant, and cotangent. Just as we've done before, we just flip our ratio or take the reciprocal of our sine, cosine, tangent functions. Okay, so let's go to an example. Okay, I take that back. Before we go on to the next example here, I'm going to show you a way to remember this, at least these first three trig definitions. And you've probably heard me mention this before if you've had me. It's SOHCAHTOA, so SOHCAHTOA. And then you divide it up into threes like this. So this stands for sine of your angle is equal to opposite over hypotenuse. Cosine of your angle is equal to adjacent over hypotenuse. Tangent of your angle equals opposite over adjacent. So that's a good way to remember these first three sine, cosine, tangent definitions. And then, as you remember before in the previous chapter, you can, once you have sine, cosine, tangent, you can come up with your cosecant, secant, and cotangent values. All right, so here's our first example, and we are asked to find the sine, cosine, tangent values for angles A and B in our figure. So in our figure, let's find where my pen is. There it is. Here's angle A, and we're asked to find the sine, cosine, tangent of angle A, and then we'll also look at a sine, cosine, tangent of angle B. But let's focus on A first. So sine of A, we're going to find the value for that. Cosine of A, again, let's find that. And tangent of A. Okay, so why it matters so much here on focusing on one angle at a time is so you don't get your opposite and adjacent side mixed around. The hypotenuse is going to stay the same at all times. It's always going to be the longest side of your triangle, or you can look at it as the opposite of the 90-degree angle. Okay, so angle A here on this triangle, if we were looking for the opposite and the adjacent side, angle A, the side opposite, whoops, sorry guys, side opposite of angle A is 36, and the adjacent side is this 77. So I'm going to name that. This is my adjacent, and this is my opposite for angle A. Okay, so sine of A, you remember that is your opposite over hypotenuse. So plug in those numbers. Your opposite is 36, and your hypotenuse is 85. And then cosine of A is your adjacent over hypotenuse. So that's your 77 over 85. And then tangent, that is your opposite over adjacent. That's going to be our 36 over 77. And we're done finding our sine, cosine, tangent value for angle A. Now let's look at angle B. I'm going to erase all this stuff over here because it changes. Now let's look at angle B. Now our opposite for angle B here is 77, and our adjacent is this 36. So this is our opposite, and this is our adjacent now. Okay, so we're going to find sine of B, cosine of B, and tangent of B. All right, sine of B, remember, just as this one, opposite over hypotenuse, but now our values have changed around. So it's 77 over 85. Cosine of B is now our 36 over 85. And then tangent of B is our opposite over adjacent, so 77 over 36. And that's how we find our sine, cosine, tangent values of two different acute angles in our right triangle. Okay, let's look at some more examples. All right, so before we get started on this next example, it deals with these identities right here that I'm showing you. These are called cofunction identities, and you will be able to write this on your note card, so don't forget to write these all down on your note card. All right, so let's look at this. For any acute angle A, cofunction values, whoops, there's my pen, cofunction values of complementary angles are equal. So what this is stating is the cofunctions are complementary. Their angles are complementary. So what we have here, it says sine of A is equal to cosine of 90 minus A. If we were to add together these two angles inside of sine and cosine there, we would end up getting 90 degrees. So these two angles inside of our cofunctions will add up to 90 degrees. All right, so don't mistake like the sine goes with cosecant, okay? Cosine and sine, those are cofunctions. And tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. So what we're going to do on our next example is use these identities in helping us solve for angles. So let's look at that. Before we get to solving for angles using our cofunction identities, let's look at this example real quick. It says write each function in terms of its cofunction. Okay, so let me get my pen. All right, so sine of 9 degrees, well, its cofunction is cosine. So remember, this is our angle A. I'm going to write this like this. Sine of A is equal to cosine of 90 degrees minus A. So the way we're going to write our function here in terms of our cofunction is we're going to say cosine of 90 degrees minus our angle that we're given inside of sine. And then just do the calculation on the inside here. And 90 minus 9, that's 81. So we get cosine of 81 degrees. And we're done. Okay, same thing goes here. Tangent and cotangent are cofunctions. So say tangent of 90 degrees minus 76 degrees, and then do the math on the inside of that parentheses, and say tangent, well, don't necessarily need a parentheses there, tangent of, let's see, 14 degrees is how it's written in terms of the cofunction. Now cosecant. Let's look at secant is its cofunction. Say 90 degrees minus the 45 degrees. And we get secant of 45. And we're done. Now let's look at our next example. All right, so we are solving this equation that we are given for theta. And the way we're going to solve for theta is by using our cofunction identities. You see how cotangent here and tangent here are cofunctions. Well, that means our angles are complementary. Complementary angles add up to 90 degrees. So one way of solving for our angle theta is by adding what's inside our parentheses of our cofunctions here. So theta minus 8 degrees plus 4 theta plus 13 degrees equals 90 degrees. Because this angle plus this one equals 90 because they're complementary. Now, just do the math. You can drop the parentheses there and add up all like terms. So we get 5 theta is equal to 85 degrees. Divide by 5 and we will get theta is equal to 17 degrees. And we're done. All right, so let's do another one just like the previous one. These two are cofunctions. So again, these two angles inside our parentheses here are complementary. So again, write it out. 5 theta plus 14 degrees plus the 2 theta minus 8 is equal to 90 degrees. Add your like terms and you will get 7 theta is equal to 84 degrees. And then divide both sides by that 7, we get theta is equal to 12 degrees. And we're done. Okay, I've kind of contemplated showing y'all this. This has kind of confused my students in the past, and we've just resorted to um, using the calculator in the next example that I'm going to show you. But here are some kind of just tips on figuring out how your sine of A and cosine of A and tangent of A, all of these values, whether they are um, greater than or less than certain values. And so um, looking at this figure here, we can say as sine of A increases, well, y increases and x decreases. And our r value is just always going to be fixed. So as your A increases, then sine of A, looking at this figure over here, that value is going to increase. And then cosine of A is going to decrease, and that's kind of looking at this figure right here. And then tangent of A, again, your value is going to increase. And then when looking at all of the reciprocal function values, whether it's going to increase or decrease, is just going to be the opposite of what the reciprocal function was originally. So if sine of A increases, then cosecant of A decreases, which makes sense because sine of A is what your y over r value, and if that number is a big value, then the r over y is going to be a small value. So let's just look at these examples I have for you next. Okay, so looking at this example here, we're asked to determine whether each statement is true or false. So from the previous slide, if we were to look at that again, on the interval, all of our acute angles is what we're looking at right here. So the interval from 0 to 90 degrees. As the angle increases on this interval, the tangent of our angle increases, just like we looked at in the previous slide. See, as A increases, our tangent of A increases. So here, that tangent of 25 degrees is less than tangent of 23 degrees. Well, that's just not true because this value right here is bigger than this one. And as our angle increases, our tangent of our angle increases also. So this is false. Okay, now let's look at the next one. Cosecant of 40 and 44 and cosecant of 40. So again, on that same interval from 0 to 90, as the angle increases, the sine of that angle increases, so the cosecant of that angle would decrease. So again, looking at this previous slide here, as our angle increases, our secant of our angle decreases. So on this right here, that as this value increases right here, then our cosecant value will decrease. So this statement right here is true, that the secant of 44 is less than the cosecant of 44 is less than the cosecant of 40. This is true. So if this just totally blew your mind, then another good way to figure out whether these values are, well, whether these statements are true or false is just by simply plugging it into your calculator and getting a decimal value. So if you plug in tangent of 25 degrees into your calculator, and then tangent of 23 degrees, replace that value here, replace that value here with whatever you got from your calculator, and look at this statement with this symbol right here. and tell me whether if it's true or false. So that's another good way of just using your calculator. Okay, so here's one of our special triangles, a 30, 60, 90 triangle. And we're going to use the Pythagorean theorem to solve for side x, and then use that in our next example. So Pythagorean theorem is one good way of finding the other side of a triangle. You may have to do that in your homework too. So this is just a leg, and here's another leg, and 2 right here is our hypotenuse. So we're going to go x squared plus 1 squared equals 2 squared. And then take the square both numbers and subtract the 1, you will get 3. So x here is equal to the square root of 3. It's actually plus or minus the square root of 3, but we cannot have a negative x value in this case on this type of triangle. So x here, square root of 3. Now after we find all of our values of each side of our triangle on this 30, 60, 90, we can find the 6 trigonometric function values for a 30-degree angle. So for this angle that is 30 degrees, we're going to find sine, cosine, tangent, and the other 3 trig values for this 30-degree angle. So now remember, 30 degrees opposite of that is our 1. So this is our opposite, and this is our adjacent, and this is our hypotenuse. All right, so sine of 30 degrees is equal to, and that's your opposite over hypotenuse, so 1 over 2. Sine next is, let's see, cosine of 30 degrees. And that is our adjacent over hypotenuse, so square root of 3 over 2. And then tangent of 30 degrees, opposite over adjacent, so 1 over the square root of 3, which we need to rationalize that. That's going to give us square root of 3 over 3. Now we're asked to find the other 3 also. So remember, do the reciprocal of each of these 3 to find the other 3. Cosecant of 30, oops, not 3 theta, 30 degrees is equal to, reverse the 1 and the 2, so you get 2 over 1, which is just 2. Secant of 30 degrees, sorry, I keep writing theta, is equal to, now that reversed is 2 over the square root of 3, or rewrite that without the radical in the denominator, you get 2 square root 3 over 3. Then cotangent of 30 is square root of 3 over 1, which is just the square root of 3. And now we're done. So we call these special trigonometric function values. We can also do the same thing with our angle 60 here in our triangle, and we will end up with similar values as we did here. You'll end up with actually all the same values, just not for the same function. So let's look at another special triangle. Oops. So here we have a 45, 45, 90 triangle. And again, we can use the Pythagorean theorem to solve for r. And that's just going to give us 1 squared plus 1 squared equals r squared. So r is square root of 2. Now, we use all three of these side values to figure out what is the sine, cosine, tangent, and the other three trig function values of 45 degrees. Let's do that. So we get sine of 45. Now remember, these are both 45 degrees, so it doesn't really matter which angle we use and which side is our opposite and our adjacent. The only thing that does matter is that r is definitely our hypotenuse. So sine of 45 is opposite over hypotenuse, so 1 over the square root of 2, which is square root of 2 over 2. Cosine of 45 degrees, it's going to be the same thing, square root of 2 over 2. Tangent of 45 degrees, it's 1 over 1, which is 1. Now find the cosecant, secant, and cotangent values. Cosecant of 45, remember the reciprocal of this value right here, which is the square root of 2. Secant is going to be the same thing. And then cotangent, again, 1 over 1, which is just 1. So again, in a 45, 45, 90 triangle, you're always going to have this sort of ratio happen for all of these 6 trigonometric function values. So let's look at this next slide. Right here. So here are all of your function values of special angles, 30, 45, and 60. And let's not forget about the quadrantal angles, the 90, 180, 270, and 360, and also 0. All of these special angles and quadrantal angles we have looked at, I will have on a table very similar to this for you to use on quizzes and tests. You just have to be able to utilize it. That's all I want you to do. So you don't have to memorize all of these or come up with these values every single time like I just came up with them on the previous slides. But here they are. You will need to use them, reference a table very similar to this in your book on some of your homework problems. But here they are for you to use, and I hope you all understood all this that I just showed you in this lesson, and I will see you later in class. Goodbye, everybody.